Scientists have discovered what could be a second possible impact crater buried under more than 1.5 kilometres of ice in northwestern Greenland. The 37-kilometre wide crater, reported in the journal Geophysical Research Letters, follows last November's discovery of a 30-kilometre wide crater beneath the Hiawatha Glacier, the first meteorite impact crater ever discovered under Earth's ice sheets. Though the newly found impact sites in northwestern Greenland are only 180 kilometres apart, at present they do not appear to have formed at the same time, and so are unlikely to have been caused by the same event. Now, if the second crater is ultimately confirmed as the result of a meteorite impact, it'll be the 22nd largest impact crater ever found on Earth. One of the study's authors, Joe McGregor, a glaciologist with NASA's Goddard Space Flight Center in Greenbelt, Maryland, who participated in both findings, says despite having surveyed the Earth in many different ways, from land, air and space, it's exciting that discoveries like these are still possible. Before the discovery of the Hiawatha impact crater, scientists generally assumed that most evidence for past impacts in places like Greenland and Antarctica would have been wiped away by the unrelenting erosion of the overlying ice. But following the discovery of that first crater, McGregor checked topographic maps of the rock beneath Greenland's ice, looking for signs of other craters. Using imagery of the ice surface, taken by the moderate-resolution imaging spectroradiometer instrument aboard NASA's Terra and Aqua satellites, he soon noticed a circular pattern some 180 kilometres to the southeast of the Hiawatha Glacier. The same circular pattern also showed up in Arctic DEM, a high-resolution digital elevation model of the entire Arctic derived from commercial satellite imagery. To confirm his suspicions about the possible presence of a second impact crater, McGregor studied the raw radar images that are used to map the topography of the bedrock beneath the ice, including those collected by NASA's Operation Icebridge. What he saw under the ice were several distinctive features usually associated with a complex impact crater. There was a flat, bowl-shaped depression in the bedrock, which was surrounded by an elevated rim, and centrally located peaks, which form when the crater floor equilibrates post-impact. McGregor says the only other circular structure which could even approach the size would be a collapsed volcanic caldera. But the areas of known volcanic activity in Greenland are several hundred kilometres away, and a volcano would have a clear positive magnetic anomaly, while measurements from Operation Icebridge revealed a negative anomaly over the area, something normally characteristic of impact craters. Although the two newly found impact craters in northwest Greenland are only 180 kilometres apart, they don't appear to have been formed at the same time. Using radar data and ice cores that had been collected nearby, McGregor and colleagues determined the ice in the area was at least 79,000 years old. You see, the layers of ice were smooth, suggesting the ice hadn't been strongly disturbed during that time. This meant the impact either happened more than 79,000 years ago, or if it took place more recently, any impact-disturbed ice had long ago flowed out of the area and been replaced by ice from farther inland. The researchers then looked at rates of erosion. They calculated that a crater of that size would have initially been more than 1 kilometre deep between its rim and floor, which is an order of magnitude greater than its present depth. Taking into account a range of plausible erosion rates, they worked out it would have taken somewhere between roughly 100,000 and 100 million years for the ice to erode the crater to its current shape. The faster the erosion rate, and the younger the crater would have been within the plausible range, and vice versa. McGregor says the ice layers above the second crater is unambiguously older than those above Hiawatha, and the second crater is about twice as eroded. If the two did form at the same time, then likely thicker ice above the second crater would have equilibrated above the crater much faster than for Hiawatha.